Welcome to Just Now Possible with Teresa Torres.
Hello, I'm David. I'm a principal product manager at Trainline, where I've been for 6.5 years, working across B2B, B2C, including touching just about every part of our Trainline web and app experience.
Hi, I'm Billie. I'm a product manager at Trainline. I've been here 4 months, so pretty new. And I'm currently working on the Travel Assistant, which is Trainline's AI assistant that supports customers during their travel, which we're really excited to talk more about today.
Excellent.
I'm Matt. I'm head of machine learning engineering at Trainline. I've worked for Trainline for about 1.5 years. Before that, I've been in ML for a number of years. Such an exciting time to be working in this space and on these products. I'm grateful for you having us on to be able to talk in some more detail about the exciting stuff we've been working on in this space.
Yeah, I'm excited to get into it. Okay, so let's just start with the high-level overview of what does Trainline do?
Yeah, so Trainline is actually the world's leading rail and coach platform. Our mission is to encourage people to take greener forms of transport, primarily rail and coach. And we're doing that by creating this kind of platform which sells tickets across kind of hundreds of train operators, and we actually sell tickets in 40 countries. Funny story was we actually started off as a phone line, hence the name Trainline. And this, when it started, was actually an innovation, because otherwise the only way to buy a train ticket was actually to go to the station in the UK and purchase a ticket at a time. So buying a train ticket on the phone was an innovation. Fast forward quite a few years, and we now have over 27 million customers, including 18 million in the UK. So we do operate at quite a large scale. And our particular forte has always been that we make buying train tickets as easy as possible. When we're operating across multiple countries and lots of different train operators, they all have their own ways of showing these products. And we bring that into one place, being the easiest place to compare prices, times, etc., and make that super, super simple for a customer. And we've always done that. And now we're doing a little bit more and really expanding and making that kind of post-purchase and travel experience even better, which is kind of what we wanted to talk about today.
Amazing. This is definitely a problem space that resonates with me as a traveler trying to figure out how to buy a train ticket in a place you've never been, often in another language, is very challenging. Okay, perfect. Let's get a little bit into how you're using AI.
Yeah, absolutely. So, as I say, we've always sold train tickets, and we've built a load of tools actually to make sure that we're selling train tickets at the best price and at the right time to customers. And I suppose when we've looked at travel, what we've realized, particularly in the last 18 months or so, is that we really have underserved needs in this space. So we see that there's particularly global trends around other consumer tech products. Think about like food delivery, right? Previously, you might just have ordered your food and then at some point it arrived. But actually now you're expecting to have a lot more information about when that's coming and what your order is, et cetera, et cetera. So you're supported through that. And train travel is no different. And we have found that there's a lot of opportunities here to use our kind of unique position of having our really great rail domain knowledge and expertise, plus the technology capabilities that we as a company have to solve problems that essentially we haven't really been able to solve before. And we've kind of split this into a few different spaces. We've split how to improve the travel experience into how do I know that what's going on? How do I know there's a problem? How big is that problem, that potential problem? And then how can I solve it? And so those three spaces are where we wanted to deep dive and apply these new technologies.
So things like, how do I know if my train has been canceled? It's now been canceled. What do I do?
Exactly, that's right.
Okay.
And that's a great example, right? Because we actually, how do I know my train is cancelled is something that we have done that for a little bit. We actually send millions and millions of messages, whether that's by push or email, actually, and both in most cases, to customers to tell them about that. But the next two cases around how do I know how severe the problem is, whether that's a bridge that might be disrupting a railway network, or whether that's just an animal that's managed to find its way onto the track, they're two very different scenarios, right? And need different solutions, and being able to provide that information to a customer. We've done that through what we're calling the travel forecast is really key. And then how do I provide the solutions to a customer? We now have this travel assistant that's live that basically can answer all sorts of questions customers might have. And we have some great examples of interesting questions that customers have asked as well.
Okay, great. So your problem space is pretty clear to me, right? Like I've been a traveler with exactly these challenges. How did you determine, it sounds like you're building or you've built and probably still continuing to iterate on an AI travel assistant. Tell me a little bit about how did you evaluate if AI could help with this problem space?
Yeah, so I think we know that rail travel can be quite complicated. There might be disruptions. It might be complicated also just you're traveling with kids and you've got 100 different bags. And so it's complicated for that reason. And so people really need support. And so a bit of an issue was like, we have 18 million customers in the UK. We can't have 18 million people at the end of the phone, although that would be really nice to support them. So we knew that with AI that we could be really scalable and we could be available to customers 24/7. We also know that LLMs are really good at synthesizing a lot of information. And as David said, we have this really big wealth of information at Trainline about the rail industry, about the network, about whether a train is on time or not. And so we knew that LLMs are a really good candidate for being able to take all of that information and then parcel it in a way that's really understandable for users. And the final thing was we knew that the solution needed to be flexible. So we did some initial user research and we found that customers were concerned with the idea of a chatbot that was very deterministic, that could only answer a certain subset of questions. They're going to come down some dead ends. It's going to be really frustrating. And so in order to build that trust and get people engaging, we actually have to be able to answer unique questions. And from speaking with our customer support team, there's common questions that people ask. People mostly ask about refunds. That's quite straightforward. But there's a very long tail of all of the other questions that they can ask. We've had people ask, can I take a turtle on the train? Can I take my motorbike on the train? They can ask anything. So we needed a solution, like an agentic solution that was able to be scalable. And I think Matt can talk a bit more about that as well.
Yeah. Yeah. So from a forecast side of things, so when we talk about just the informational side, I think, yeah, it was fairly straightforward to determine AI was the solution. Summarization is a well-trod ground, right? When it comes to the travel assistant, though, that was because this was October 2024, so 1 year ago now. And we started talking about it in August of that year. At that point, LLMs had been around in the public domain, widely used for about 2 years, but were they capable of reasoning? That was a big question at the time and something that could unlock potentially these agentic use cases. And particularly in the UK, no one had put out this kind of solution at the scale we were proposing doing it. So what we really wanted to do was get a sense of, could the system perform reliably? Customers can be in diverse situations. They could be on a train on the way to Manchester. Their train might break down. We need to be able to answer questions at that point. Whereas my train, when is it likely to arrive? Or they might just be wondering, could they bring their dog onto the train? So it's a really diverse set of questions. So we wanted to validate, firstly, could the AI reason well enough to understand the tools it needed to call, the actions it needed to take? And secondly, could it do that in a reasonable time? Right, with a reasonable level of accuracy, a reasonable level of reliability, right? So that's really what we wanted to validate. We built a POC in 2 months to do this. We validated it, we did some human evaluation. And then from there, we went on and we got it into production 3 months after that. So we went from 0 to delivery into production in front of our customers in roughly February 2025.
Tell me a little bit about that POC.
Yeah, so a proof of concept was essentially, so the approach we took, we can dive deeper into the architecture in a second, but the approach we took was a kind of central orchestrator, and we had a number of tools. So we had a very simple vector database. We had a terms and conditions tool. And that was basically it, basically. It's like we wanted to check to see if it could choose when to call terms and conditions, when to do a more general information check. We also had been partway through the process of integrating first action, which was to be able to offer customers refunds, right? So what we did find with that POC was that it could reliably, when a customer asked a question vaguely related to terms and conditions, it would call the T's and C's tool. And when they asked a more general question, it would call the information retrieval system. we did have a mock refund endpoint as well. And we did find that obviously when they asked about refunds, it did call that endpoint. So that gave us enough confidence to be able to push forward and build a production ready system.
So your POC was truly agentic from the start. You gave it a RAG step, you gave it a terms and conditions tool. And I'm assuming like every rail provider you're working with has its own terms of conditions, and that's all available through that tool.
Yeah, so we're lucky at Trainline that as I said, we're a 25-year-old company. So we've got these kind of systems that we could potentially reuse. The approach we took to building this, though, was quite interesting, actually. We had to take a bit of a bet, I think it's fair to say, on the architecture. It was still emerging at the time. Like, from 1 year on, it's crazy to think how far we've come in a year. But at that point, there was no kind of standardized architectural approach to these kind of things. So we decided some principles that we wanted to build the system on. Number one was we wanted to stick to good engineering principles, have a separation of concerns, both in terms of the way we structured the tools and structured the agents, and also in terms of the way we structured the services. So we realized for POC, we needed to, put in the extra work to try to build out those foundations from day one. And number two is more, I guess, the principle of how the state graph, let's call it, the orchestration would look. A single central orchestrator with tools around it. They could be agents or they could be simple API calls, but this single point of truth that would manage the inputs from a customer and also manage the outputs.
And was that first orchestrator, was it an agent working in a loop, deciding when it was done, or was there a little bit more workflow to guide it along its path?
Nope, it was an agent working in a loop, deciding when it was done. We took a very bold approach, and yeah, we've heard from several of our kind of partners that we work with that we were quite far ahead at the time. So yeah, it was very bold, but we think it's paid off.
Okay, so tell me about that 5 months. So you have this. You started from the very beginning with kind of an agent plus tools architecture. You gave it a small number of tools. You stubbed out an action. I'm assuming one thing that you had, which I could imagine was really valuable, is you knew what people were calling in for help with. You had a clear sense of, I know it could be anything. Can I bring my turtle on the train? But you had visibility into the types of things people needed help with. Is that fair?
So yes and no, actually.
Okay.
Because it's to bear in mind, like up to that point, to access Trainline customer support, you would either have to phone or go out through the web. So there wasn't really a native in-app customer support system before the assistant, right? We had an idea in terms of why people contacted customer support, but bear in mind what we were doing here was really making it much easier, lower friction for customers to contact customer support. We were guessing at that point, but that's the reason why we took that 5 months and tried to roll it out to production. I think what Billie can probably talk more to is actually the interesting bit is once we got it into production and how we iterated from that point, because that's the point we started to see what customers were actually asking us. And I think there was some surprises, actually. We expected it to be just refunds, but we're also seeing other stuff.
Yeah, I think it's really interesting because the biggest contact reason for CS is refunds, and that is definitely reflected in the assistant. Like a lot of people are coming through and asking for refunds, but usually when people contact customer support, it's right after they've bought a ticket or it's right after they've traveled. It's not during the travel. It's not while they're on the train or while they're getting to the train. And so what we've seen with the assistant is actually people who are on lower familiarity journeys. So journeys that they haven't done before, or riskier journeys in quotation marks. So ones that they've booked maybe a couple of months in advance, or they're very expensive, or they're traveling with kids or lots of bags, as I said before. Those are the people who are actually asking the assistant questions, and they're asking questions that you probably wouldn't call up support and ask, but are actually those like reassuring questions. My toddler is going to need a wee really soon. Is there a toilet at the station? What platform is the toilet at? Or I've got a really early train and I'm not going to be able to get breakfast before. Can I get breakfast at the station? Is there a Pret or something that I can grab before I get on the train? So it's those kind of reassuring questions that people are asking, which we regularly review the types of questions that come through to the assistant with our customer support team. And some of the questions that we were showing, they're going, wow, we've never seen this before. So it's really interesting that we can provide that reassurance to people while they're traveling.
Yeah, I think what you're describing is one of the hardest challenges with these like very open-ended agents is your agent has to be prepared to respond to anything. And I think this is where LLMs almost become dangerous because they will respond, but it may not necessarily be correct. So tell me a little bit about, I'm assuming, like, did you have that information? Do you know what food is available on different trains and at different stations? And I'm curious about, especially in the early days, how did you decide what use cases you would respond to? Did you give the agent guardrails for what not to respond to?
Yeah, so effectively, so I'll talk about the early days, and then I think we can talk more generally about the kind of information Trainline has. So the early days, we wanted to cover the frequently asked questions.
Yeah.
We wanted to cover the terms and conditions of their ticket. And that was basically it. That was like what we perceived would be the minimally viable product, right? You need to be able to tell a customer what are the parameters of a ticket you booked, and then, answer basic stuff. We've since expanded that to about 700,000 pages of Trainline curated material that we have on our website, already built for SEO. What we do is we essentially take that and we do some clever processing and we put that into a vector database. But then it's not just that, it's also real-time information. So we have a real-time API, and the assistant can in real time call this API and get exact positioning of the train, get an understanding of where it is in terms of its journey, whether there's instances, if there's a cow on the track, if an escalator is broken at Waterloo Station. So it has this array of information it has access to right now.
Okay, so it sounds like one of Trainline's strengths is it has all these information sources, whether it's real-time train data, data about stations, data about maybe what's available on the train. And tell me how you iterated from, we're just going to handle terms of service to, and I'm also curious about like when you just offered terms of service, how did the agent respond to things that were outside of that terms of service? And then how did you iterate through these different use cases and get to 700,000 pages of helpful response data?
Yeah, so I can talk to the guardrails, let's say,
okay,
and how we manage those responses. So obviously, Agentic AI is really interesting because it's an art and it's a science, right? And it's a craft to some extent, I would say. In that, if you want to make a change, if you want to affect this system, I would say there's several ways to do that. You can do it in a prompt. You can build an external guardrail. You can change the structure of the tools you use. You can add validation checks on the tools you use. We do all of those things.
okay.
We have a guardrail check in. We have a guardrail check out. The guardrail check out does a contextual grounding check to check that the assistant's response is actually based on the information it's been given. In all of the main tools, or many of the main tools, we're passing the data. We also, inside what we call the information retrieval service, which is where the RAG happens, we have a specific LLM there that is basically almost a judge in a sense. It takes the information in, considers if it's actually relevant to the problem, and it passes it back to the orchestrator. It only passes that summarized context back to the orchestrator, essentially. Inside the prompt, we have very clean prompts now that we've read on over many months. And inside that prompt, there's some very clear directives in terms of what it should be able to answer, what it shouldn't be able to answer. In the early days, we leaned heavily on that prompt, right? We had our guardrails in place from day one. Safety was always really important. Factual answers was always really important. But inside that prompt, we wanted it to be able to respond in quite a human way. Sorry, I'm not able to help with this right now, but this feature is coming soon, that kind of stuff. I don't know, Billie, if you want to talk more to that in terms of how we're still handling it as well.
Yeah, so I just wanted to say, you were saying, Teresa, you could ask anything. That was actually a conscious design choice when we were looking into the UX, to have just an open free text chat that people could type anything in. And that was partly due to some initial research that found if we had too much prompts and too much guidance, people felt like they weren't actually talking to a real agentic system. Like it's probably just a decision tree, or it's not going to be able to help me here. But also it's really valuable data for us as product managers. We're in beta testing now. We've got 300,000 people having conversations every month. Like this breadth of data that we're getting in, unprompted, seeing the types of questions that people are asking, it's super valuable because it means we can go, okay, we've got all the guardrails, so we're not going to be answering the wrong types of questions, but we can also see, okay, these are the questions that people have. This is where we can expand. So in terms of the development, it's really interesting. And just the final point on the guardrails and the things that people can ask, it was also very important that if we weren't able to help a customer, we could hand over to a human agent really seamlessly. I think that was a very important principle right from the start. So if the assistant knows that it can't help a customer, it can't move forward with a refund or something like that, they're passed over straight away to a human agent. And that mostly happens within the chat, so they don't have to leave and the agent has all of their context. And then there are also cases if there are things that we just don't feel comfortable touching from the assistant. So if people say, I need a refund because someone has passed away or I'm really ill or things like that, just straight away we're handing over to a human agent because we know that in those situations it's much more appropriate to be handled by a human than by the assistant.
It sounds like maybe one of the first things that's happening is there's this guardrail of, is this appropriate for the assistant to handle, or does it need to be routed to a human?
Yeah.
And then if it's determined appropriate for the assistant to handle, there's this retrieval step. And Matt, I'm starting to hear this common pattern where a RAG step is not just like an embeddings database search, but it's actually an agentic step, making sure that what's coming out of that embeddings database is relevant to the user's query. And I think that's probably come up in my last 3 or 4 conversations. It seems like it's definitely becoming a pattern of, we don't want to just rely on semantic search. We want to take advantage of this LLM to interpret how do we do, and maybe even try again if needed. So I'm curious to dive into that a little bit. And then it sounds like even after that data is pulled back and the agent can respond, there's also some additional checks around, are the responses grounded in our data and that the LLM's not pulling in sort of extraneous data? Is there other stuff that's happening in that? Are there other checks in that process?
Yeah, so it might be helpful if there's sort of one end-to-end through the kind of process very quickly. And to your point about RAG, yeah, I mean, there's always talk of is RAG dead? And I don't think it's dead, it's just augmented, basically, in itself, which is quite funny. So the guardrail text comes in. We then populate, to be quite technical, we populate the state. So we give the agent all the information it needs to know about the customer upfront. This is like metadata, etc., information about his ticket, their ticket, etc. The agent then called. This is a reasoning call. It has access to many different tools, and we're growing these all the time. Real-time tool, journey itinerary tool, information retrieval tool, terms and conditions tool, refund tool. It also has certain commands that it can send back to the back end. Switch me to a human is one of them. So it makes that decision. And that might go to the RAG system. It might retrieve, or it might just call an API. It might do multiple steps. Then comes back to the orchestrator. The orchestrator has a choice to end. If it does end, it will go via the guardrails out, which will then do a contextual ground check plus a toxicity check as well, just to check nothing really dangerous is going through. And then ultimately that gets sent back to the user. But the assistant also has the option to keep, calling separate tools. And in fact, one side note to say is that early on, that was one of the major problems we saw. We gave it the directive to help the customer, and at times it was very persistent in that and would not give up and eventually get stuck in a loop of keep trying to call tools to achieve its objective. So that's one of the challenges we face with that. But yeah, as you can see, it's a very kind of open graph, and it allows for a lot of creativity, but within the safety of several layers of guardrail checks.
Yeah, one thing I'm curious about, like even just this problem of one challenge with agent loops is, does it ever end? And then also, I think another challenge is, especially with the chat interface, like latency must be a huge concern. So what are some of the things you're doing to make sure that the chat responds in a reasonable time frame?
Yeah. So the way we positioned this initially, and David, it'd be good to get your perspective on this. The way we positioned it initially was what we're comparing it to is a human response time, right? Which on chat does take some time depending on the time of day you contact, etc. So what we found initially is the response time was about 12 seconds, right? And the bottleneck of that is like the number of reasoning calls, right? So every time it makes a reasoning call, you've got to wait until the last token comes through before you can take the next step, right? So that's the kind of challenge. What we've managed to do by working with our partners at AWS is using different, I guess, ways of doing inference, like being able to route to different servers across the EU and UK. And we've managed to get latency actually down to, I think last time I checked, the average was about 5 to 6 seconds, which is pretty good for this kind of system. But at first, our priority was if a customer has to wait an extra 5 seconds to get the right answer, is that the end of the world? Probably not. If we give them a wrong answer within 1 second, that's not very useful. But I don't know, David or Billie, do you have anything to add to this?
I suppose that's the other side of the equation is how we manage the user expectations with that, or how we present the fact that there will be a lead in the response time, and how we, whether that's through loading animation or whether that's through ensuring that we provide information to customers to say, hey, yeah, there is a response here waiting for you. There are things that we have done, there are things that I think we can do as well to improve on that. And I suppose that's that we want to improve the speed, but we also want to improve the understanding that the human that the user has on the other side of it to say, yeah, okay, I understand that what's going on. I understand that there's going to be some sort of latency here and there's going to be some delay in the response. And hopefully the answer is worth the wait. I'm sure it is.
Yeah, I think this is an interesting space from a UX standpoint of like, how do we set that expectation with the customer? Because yeah, is 5 seconds really a long time to wait? Not really, except for when we think about you don't wait 5 seconds for a web page to load, and although some web pages take that long, right? So we're looking like this is also, especially with chat, like I think some of the early, especially decision tree chats, like some of them are fast, some of them are not fast. We mostly hate them because they're not fast and they don't solve our problem. There's so much baggage that comes along where we have to set this expectation with the customer. This is different. We are going to answer your question. It might take a couple seconds longer. I'm curious what you're learning there.
I think what you're saying about it's an interesting opportunity in the design is really key. So I think right now what we've got, we are confident that it's fast enough. 5 seconds is fast enough. As Matt said, like as long as you can get the correct information at the end of the day, then it's okay. But there are definitely things we're thinking about with the UI and like patterns of animation. And I've seen with other AI companies and LLM, their animations, like describing what's happening. Sometimes that can help, just saying, okay, we're achieving all of these documents and then we're thinking about what to do next. And then we're writing a really good response. That can help because you're not just staring at a blank page going, is this working? Am I ever going to get a response? There's that expectation that actually something's happening and you're going to get a response soon. So I think with the UI, there is a lot that we can do to set customer expectation, but it is definitely a balancing act. I think when you're working with generative AI, speed is always going to be something that you're thinking about, and it trade-off and decisions that we're continuously making as we continue to build it.
Yeah, and also the context of the user as well, like on a train, that they might be rushing, I think as Billie describes, like that situation, we don't necessarily know situation that the user is in, but wanting to provide the answer that they can get and they can get in the right level of time is really important. And particularly if a response that's going to take longer than that, the situation might well change on this train. We're getting data continuously fed to us, but we don't want to be giving a response that's then incorrect just after having taken slightly too long to come back.
It's worth just mentioning in terms of the other product we mentioned earlier, which was the forecast product, which is static summarization. That's also a similar challenge there. And the way we solve that is essentially these million messages coming in. We just do it when we receive it and then we cache it. That's not possible in the assistant because the questions are so diverse.
Yeah.
But it comes down to the application specifically and what strategy you can use to either, as we discussed, make it seem less long to the user, it will stop the user getting frustrated, or is there technical strategies you can follow to make that time not matter?
Yeah, I think we're starting to see some cool patterns. I know, Billy, you mentioned animations, and I think this is something that Claude Code in particular excels at, is just giving you a little window of I'm still working away, so just be patient. Matt, you raised something that I want to dig into a little bit, a few things. So I am curious about if you can share, like, how did you solve this challenge of the agent is just too persistent and doesn't want to return? Let's start there, and then I want to dig into the architecture a little bit more.
Yeah, so there was a couple of elements to it. Number one is when we rolled this system out quickly and we kept adding more tools, and you can imagine the prompt became quite long, and each time a different engineer would come in, add something to a prompt, etc. And so we found that was actually part of the problem, right? So there was partly that single directive would be very helpful to the customer, but then also this kind of long spaghetti prompt needed to be solved. We needed to do that at the right time, though, because it was a trade-off between moving faster and then fixing that. So we took the time to fix that. That solved half the problem. Clean prompt, put more of the logic into the tools, think about tool structure. That really improved things. Secondly, we put a hard limit on the assistant. Like I said, you can do this 6 times.
Yeah.
And then you either you deliver a no response, or this will end, basically. So that was the other strategy. But yeah, really, we just saw it gradually improve as we cleaned the prompt, became more mature in terms of the way we were structuring the tools. Before, for example, we had a real-time tool where it would just give the assistant like a really long JSON about everything it possibly needed to know. We found that actually breaking that down into separate tools was really effective, reduced kind of hallucinations, which then stopped this kind of recursion error. But yeah, I'd love to say, Teresa, it was one big thing, but what it was careful engineering really that solved the problem.
It's funny, Anthropic put out a blog post about effective tool design for agents, and it's really interesting that this is becoming a skill, and it's very different from the standard like engineering decomposition skill of, we tend to think when we create API endpoints, we want them to be like the REST tied to a resource. You can get it's the standard get, put, whatever. And then you move to tool design and it's, no, actually I have to manage for the context window. And that is a very different design problem, design pattern. And it's fun to see how we're all learning this kind of at the same time. And then I remember I read that Anthropic blog post and I was like, oh, this is why all the MCP servers I use are terrible. It's so funny. We all have to learn this. And then it introduces this new pattern. And then we apply that pattern. We're like, oh, we actually get way better output from this because we're learning that this is a different pattern than like an engineer using an API endpoint.
Yeah, it's definitely a skill. I'm interested, actually, Billy, if I can ask a question, because when you've come into the system and worked with this agentic system, what were some of the learning curves that you found when you joined the team when it came to some of this stuff around tool design and the prompt and what to put in the prompt when to add a new tool?
Yeah, I think with the prompt engineering, I was surprised how long the prompt was when I first joined, and I got shown the prompt and I was like, my gosh, it's really long. There's a lot happening in there. And so just being able to get a peek behind the curtain and seeing that, I was surprised by how long it was. And I think we've tightened that up a lot as we've gone on. In terms of the tools, I think something that I've been keeping in mind, which can be a little bit difficult, is if you're making one tool better or making an improvement in one tool, you don't want to have unintended consequences somewhere else. And so I think that's where we come more to the evaluations and stuff. But with Matt was saying, for example, with our information retrieval tool, we went from about 450 documents to 700,000 documents. And in terms of the information that we can get out, that's brilliant. And that's a huge breadth. But I'm also thinking in the back of my mind, okay, are we increasing latency, or is there some unintended consequence down the track? So yeah, that's another thing that I've had to keep in mind with this agentic system.
Yeah, Matt, I love that you just asked Billy that question, because one thing I'm really interested in is For product managers, this is also a whole new space. And like a lot of us, first of all, engineers barely understand how to do this stuff well. And now we're asking product managers to jump in and be technical, because you can't really be an agent product manager without knowing some of this stuff. Billie, did you have some of this background coming in? Did you have to learn it on the fly? What did that look like?
So I was lucky in the sense that I worked in an AI startup before this. So I'd been around AI for about 6 years. So just learning through osmosis from some really brilliant people around me, which has definitely been helpful. And then before I moved to Trainline, I was also working on an MVP of a generative AI assistant. So it was much earlier stage than what we're working on here. Like even just in the time of me moving companies, like the technology had come on so far. So I felt like I was having to get up to speed all the way again, but I did have a little bit of the basics, which has definitely helped.
Yeah. This is really what inspired this podcast, is that we're all just trying to level up as fast as possible. And it's hard. I think it's tremendously fun, but it's hard.
I think one thing that's interesting, but also tricky, is just the rate of change. And so you can't rely on, when I previously thought this wasn't possible, so we can't think about this. And then 3 weeks later, suddenly it is possible. And so you have to completely change all of your plans. And so you have to work in really close partnership with your machine learning engineers, because they are the domain experts. And a lot of the time they can tell you what's just now possible, which wasn't possible like a couple of weeks ago. So yeah, that's the rate of change is obviously really exciting, because if you can't do something, you can be sure that in a couple of months, maybe you will be able to. So that's nice. But also you have to be able to pivot really quickly, and in order to keep up with what the technology can do.
Yeah, I keep hearing people describe this as if you're building AI apps, you want to be right on the edge of what AI can do. Otherwise, you're probably going to get cannibalized by the labs pretty quickly. But it's also exhausting, right? Like for me, I'm juggling both. It's so fun. I remember Anthropic came out with the Files API, and I was like, can I use a beta feature in my production app on day one? Sure, okay, let's see how this works. So it's super fun, but it's also, are there things that you're doing to keep up to date on this stuff, to make sure it's not also exhausting? Like, I'm just curious about what teams are doing to manage just the insanity that we're living through, even if it is fun.
I think just there's so much information. I know for me personally that the amount of people that are talking and writing about this is incredible. And that makes it so much harder to keep up as well. I think as an individual, it's impossible to keep up. We try and work a little bit as a team to do this, where we have shared resources, shared information, and can cross collaborate, help each other with that. I think it's really key, particularly from a product manager perspective as well. There's particular elements that I think are more geared and really help us try and understand the technologies, as opposed to sometimes really getting caught into the details, which can really blow your mind about what we're able to achieve now. And I think the other thing is that it just proves the value of being closer than ever before, really, to the engineers and to the team that you're working with, because actually sitting there, living their life, breathing kind of what they're doing as well, means that you get that much better understanding quicker and quicker. And the closer you can be to the team and to the engineers and to the technologies that are being used, and then that part of what is possible, means that we can make better decisions. And that trio or that pairing, however that might look, coming together and being closer is super key, more than ever at the moment.
Yeah.
I love that response.
I definitely agree with that in seconds. I think actually Trainline, is really good for this. I've worked in ML for a while before it was cool to work in ML. And so interestingly, not all companies, you don't enter a discovery stage. You used to get kind of a solution passed under the door to you, go and build me a model, bring it back. And I think what's great at Trainline is we're very much an ML team. We're there early, we're informing. Maybe you could actually think about this problem a bit differently now because this has just been invented. For us, we've always read papers. We've had to keep it. Our jobs have literally depended on it. Things have always changed every year in machine learning.
Yeah.
But what's really exciting for me now, and I think my team, is like being able to be more involved at that discovery stage than we would have previously, I think is, just really powerful. And Trainline is, I'd say, very good, best in class at that.
Amazing. Okay, there are two more areas I want to dig into. Billie, you framed it as we went from 450 pages to 700,000 pages. And is this going to slow things down? And is it going to work? So I do want to get into your retrieval step and just talk a little bit about what did you have to learn to make that work well? I know you already had a lot of information on your website, but I know that how we serve data on our website is not the same of how we make it easy for LLM to access. And then I would love to get into evals because I know that like you're doing real-time customer conversations. So how do you know it's any good? So why don't we start with your retrieval step and what iterations did that have to go through to get it to work well?
So in terms of a retrieval step, so we built the Vector database to be scalable from the start. So in terms of from an infrastructure point of view, there wasn't necessarily anything like difficult about that. But in theory, but then there was lots of small problems. So firstly, actually getting the data, obviously like the CMS systems aren't designed to just give a kind of database or a system. So we had to do a kind of internal scraping of these pages. And then obviously HTML markup isn't necessarily always good to just stick straight into a vector database. So there was a lot of very specific parsing that needed to be done to break down different types of markup, etc. Then the next problem was, well, from a retrieval point of view, some of these paragraphs on these pages are quite long and detailed and cover a number of different subjects. And I can give a very good example is it might talk about seating for the Eurostar. And you need that context about the Eurostar for the semantic relevance to work when someone's asking about Eurostar. But then if you include the entire paragraph, you end up getting too much context back, and that was leading to hallucinations in some senses. So we were using a kind of semantic chunking that we had to really refine to get that right, to be able to make these 700,000 pages sure they were being retrieved at the right time. The challenges didn't stop there. So then the question comes down to we're using a number of different sources. All of them are pretty up to date. You've got the national rail like guidelines, you've got industry like information, you've then got Trainline specific information, and you've got train company specific information that they've given us so we can put on our website. And all of this, it doesn't necessarily contradict, but there can be nuances in terms of the information hierarchy. There's rules in the rail industry, but certain train companies might do more or offer more compensation in certain scenarios, etc. And navigating these kind of problems was quite difficult. And this is what really helped us, to be honest, was having that LLM there to be able to reason through the top 10 pieces of information we retrieved. So yeah, there was endless challenges to it. And yeah, there was one engineer on my team, I have to shout out Karishma. She pushed through, managed to get this to production.
Yeah. Okay. I love that, even just that specific example of you have different sort of sources of information. They kind of layer onto each other, right? You might have a regulation, you have to compensate a customer this much. Then you have a carrier who might say, that's great, but we're actually going to give you a little bit more. And so you have an agent that's trying to understand the context and not just parsing from a single document. Here's an answer, but here's the answer that you need given your context.
Yeah, exactly. So it was quite challenging. And yeah, again, I'd love to say there was one big answer, but again, it comes down to very careful engineering, really understanding how RAG works, really understanding what kind of chunking strategy you're using. It's these small things that really get you to a place where the system works reliably.
I imagine too, you had to really be thoughtful about like even just how to label data. Is that true? Like even just this example you gave around like, this is maybe a regulatory answer, this is a carrier answer. Are there things you're doing to help the LLM understand like how these things might layer onto each other?
Yeah, so there's metadata associated with each entry. And that metadata is given to the information retrieval LLM.
Yeah.
So it can understand, firstly, is it a recent document? Is it a document from a certain source, etc. So there is that kind of mediation, and there's that metadata there to assist the LLM with that task.
I feel like Retrieval is bringing back all the librarians into our work of how do we structure data in a way to make it useful for an LLM to work with.
I think there's a really interesting point as well, though, where one of the things that we have to now do is iterate almost before we have a product live, much more than perhaps being able to ship something. We know exactly how it's going to operate and then be able to move on and make the next change. That step has almost moved a lot earlier in the development cycle, whatever product that we're building. Just because of the nature of non-deterministic products means that, I suppose, step just moves so much earlier in the process. And that's something that we see across all of the products that we're building. And it's a big change in mindset, I think, to do that earlier and understand the importance of that. But it's a really interesting change in how we build software products, I think.
Yeah, this is also a common theme I'm seeing across products, is this idea of like companies that maybe didn't have this muscle, or it was, like you said, a post-release muscle. Whereas even just to understand the feasibility and what's possible with LLMs and what makes it good requires a lot of that iteration before it's ready to put in front of a customer. I think this is a perfect segue into, let's get into how do you know your assistant is any good? Tell me about your eval strategy.
Okay, so I'll start by saying that evaluation has always been, and is, in my opinion, the most challenging area. It's the most challenging thing about machine learning, like generally. And as ML people, our instinct was to evaluate this system like any other model. So it's about starting with a problem. It's, okay, let's break that down to specific model metrics that we can use. Let's ladder that up to business metrics. So for the forecast product, where we're just summarizing the travel information, very straightforward. We create a golden data set, basically do some kind of semantic comparison, job done, right? For the assistant, very different beast altogether. The general purpose nature of it, customers could ask 1,000,001 questions. So yeah, where do we start? So we start with some principles in terms of what were the areas we felt that we needed to evaluate. So first was like groundedness or factuality. Is it offering factual responses? The second was, is it offering relevant responses? Are the responses helpful? And then finally, are they consistent, right? So those were the four kind of principles. Then the question comes down to how. So obviously we built this product really quickly. So we first leaned on human evaluation and what I'd call small scale automated tests, right? So we had certain tests where we do some semantic checks to say, yeah, this response is quite similar to this for certain key questions. But other than that, we just set up controlled human evaluation. We did outsource some red teaming. We felt that like checking for toxicity, making the system safe was the most important. So we outsourced that to a third party. We also did a number of red teaming rounds inside the company. And so it was really that split between red teaming, where you unleash your chaos and try and break the system, compared to this carefully controlled human evaluation, where you're trying to understand, like, is this system good enough from a customer value point of view? So that's where we were at launch. I'm happy, unless you have a question about that, I'm happy to continue to talk about where we are now effectively.
Yeah, please do.
Okay, so I became very interested in reference-free evaluation or minimal reference evaluation, let's say, i.e. LLM as a judge. And I actually became very interested in this mid last year before we even built the assistant. So we knew from day one, that's where we would probably have to go to scale. And and the team also was becoming really impressed by some of the results that was in the literature in terms of LLM as a judge. It's amazing. Who would have thought it would have worked? But the human alignment you can achieve with this is incredible. So we knew what we wanted to build. We wanted to build an all-in-one observability platform that allowed us to essentially log, to monitor online, and then also evaluate offline, and have the offline and online evaluation pretty consistent, using primarily judges as well as some more traditional checks. So what we did was we put our spec in terms of what we wanted, and then we looked at a couple of other companies, and Brain Trust actually came along, and we saw their product and we were like, wow, this is exactly what we want to build. So we've actually got that in now, and we are now in the steps. We've set it up, and we're able to run offline evals according to those first principles I set out. We have a number of judges set up. This works for both online and offline. It gives us a huge amount of observability, which will come on into a sec. But there is one area, Teresa, that I do want to cover. It doesn't solve all our problems in that trains are very specific. And as we said at the start, you're on that train to Manchester. How do I offline evaluate that? How do I replicate your exact situation to be able to understand your train's delayed by 5 minutes? You're an angry customer and you want to know what we can do. So what we've also built, and we felt we needed to build this in-house to accompany Brain Trust, was what we're calling a user context simulator. And what this effectively does is it buys tickets in our test environment, lots of tickets, and then it samples anonymously previous user queries, and it creates lookalike queries based on the context of that ticket, while a real train in real life is actually moving and in a specific context, right? So it then simulates all of that, puts that into the assistant, and then en masse, we can evaluate basically anything we want. We could roll out a new type of product, say we want to maybe give more directions about other trains to customers. So all we need to do then is give that direction to our user context simulator, and it will then just generate those types of queries for a user. So we're really excited about this. We think we're really onto something with it. But yeah, long story short, that's where we're at.
Okay, that is amazing. I really wish we had gotten to this half an hour ago, but that's okay. We're gonna cover it as much as we can in the time that we have left. I want to make sure I understand though your evolution. So it sounds like when you launched with data set evals with human feedback. So you have collected some use cases that you think were going to represent what you were going to see. You had humans evaluate the output. You scored your agent based on that data set. Matt, I want to ask you about, you started to read about LLM as judges. You knew you wanted to use that. Tell me a little bit about what motivated you to want to shift to LLM as judges. Did you see a gap in using data sets? Because I think there's a lot of product teams out there that equate evals with data sets. And I think it's hard to communicate why you might need more than that. Do you want to share a little bit about how you thought about that?
Well, for a company like Trainline, I would ask, where do you get that data set from? Large-scale AI companies are hiring teams of AI tutors now to be able to, they do reinforcement learning, but originally it was for labeling certain data, certain prompts, etc. For Trainline, that's not an option to do on a large scale. Like customers could ask us like 10 million different questions. And we've had this in production 5 months. We've had a million conversations now. And how do you predict what those million queries are going to be? And how do you label those? Like you'd have to hire a huge team of people to do that. Yeah. So my interest in LLM as a judge, and the thing that really excited me was that people were able to achieve high human alignment. So what does that mean? That means you can have a smaller team of human labelers, and then you can scale that and you can align your judge with that. So you can effectively scale the human judges that you do have across those user contexts. So for me, when I read those papers, I was like, wow, I wasn't expecting this. I didn't believe high human alignment in those cases was possible. And when time and time again, researchers were showing it was, that for me was a breakthrough moment.
Okay, so it sounds like really the primary driver was scale. And I think this is a really important point to clarify. So when we start with data set evals, your data set evals are only as good as your data set, right? So you have to curate a data set that you think represents what you're going to see in production. And it only is evaluating sort of the footprint that data set covers. And especially with the agent where people can enter anything, there's some risk there. I'm curious for David and Billie, were the two of you involved at this initial data set curation step? Were you familiar with evals? I'm also really interested in just how product managers are getting up to speed on what was a very machine learning specific skill in the past.
So In my previous experience with generative AI, it was over a year ago now. And so a lot of our evaluations were just like, we have a human labeled data set and then we evaluate based on that. And a lot of that is squinting at it a little bit and going, I think this is better, like generally, but obviously I can't ask every question under the sun. I can't have every single user experience. I can't do on every single train for Trainline. So it was a lot of just squinting and being like, I think this is better. I hope this is better. And so what was very exciting when I came to Trainline and Matt was telling me about LLM as a judge in this evaluation is just the scale of it. But it wasn't something that I'd actually heard about before. So this is pretty new to me and it's very exciting.
Yeah, I think same for me. It was very new. I think the thing that is particularly interesting to me is that we've gone from spreadsheets with what we think is the right answer and the answer that we're getting to something that's now much more advanced. But even as we do that, we're still finding now that the answers that we're getting are not necessarily, we don't necessarily agree whether it's the right answer or not. And so the kind of the non-deterministic nature of the output that we get means that it's really, really subjective, right? No matter what the question is, there's always going to be some element of that you can disagree on or you can have a different opinion on. Yeah. And I think that's something that from a content design and from a product perspective, like we're going to have to get comfortable with getting uncomfortable with that, understanding some of the trade-offs that we're making there a little bit better and the risks that we're facing. And I think that's going to be a really interesting area to understand better as we kind of develop these products more and more.
Okay, so we started with data sets. We started to move into LLM as judges. Matt, you outlined you had these 4 metrics. I'm assuming you have LLM as judges evaluating those 4 metrics on your outputs.
Yep.
And it sounds like you're doing that both online and offline.
Yeah.
Okay. And then David and Billie, were you involved in the sort of human alignment of those judges?
This was before I joined. So
okay.
Yeah.
This one, so we are, for the brain trust work, we are using the previous evaluations that we've done in terms of the human evaluations as initial alignment, but we're still aligning them. It's all very new.
Oh, so you're using your data sets to align your judges.
Yeah, and then you can, because the idea is you can then keep a whole back data set and then you can evaluate how close you are to, that's the method. You essentially evaluate the alignment that you have.
Yep.
It's similar, you're basically testing the judge, and if you can demonstrate high alignment, you've basically scaled up your human judge.
You know what's interesting about that? That's a little bit of an aha for me. So I have aligned LLM as judges, but I've always thought about it as this is a separate task. But if you start with data sets and you evolve to LLM as judges, you can use those exact same data sets to test the alignment of your judges.
Yeah, as long as you're keeping good practice and you're not muddying what you give to the judges, you're maybe few short examples.
Yeah, you don't have data leakage. You want to make sure that it's all, exactly. Okay.
Yeah, exactly.
So then tell me about, so you've got your 4 metrics, you have LLM as judges, both online and offline, evaluating how you're doing. You're confident about human alignment because of your original data sets. Tell me what gap did you see that drove the need for this sort of user simulation that you built?
Yeah, so it's effectively, so we could evaluate, for example, online, because you can take like the ticket, etc. But when it comes to offline evaluation, customers are asking us like, what platform is my train going to be on? That customer might respond. So for example, let's say it's platform 4, and then the customer responds by saying, platform 4, I thought it was platform 5. They're challenged that, right? And so you need to simulate that scenario where actually there's a kind of surprise. So we thought, how can we do this? How are we going to find a ticket offline that's exactly relevant to a specific conversation?
That's in the past.
That's in the past, yeah. How are we going to do that? So we're like, let's not start from that. Let's start from the ticket. Let's buy a ticket in our test environment that does relate to a real train in real life. And let's actually get a kind of LLM, a judge, that we essentially specialize to pretend to be our customers. It samples in real time, like real customer queries, and then tries to then augment that to become relevant to the ticket that is just bought. it does this 100, maybe 1,000 times with every ticket. And then we just repeat that process. And because we've integrated brain trust, then we can just utilize all of the judges we've got in there and the monitoring. And I should say this is very new. We have only just built this. So we haven't battle tested it, so to speak. But so far, with the team this week, we've been running our kind of first evaluations using this technique, and it seems to be working relatively well from what we can see.
Okay, so I want to make sure I understand, because I think this sounds pretty spectacular. Because you have queries that really depend on real-time data, you're trying to test, are we giving the right responses real time? And so you have to simulate, like, I'm on this train, I have this need over here, and you're taking like past real customer tickets, not train tickets, like support questions, applying them to a current ticket to see if you can respond with the right real-time data for that ticket, for that.
Yeah, exactly. Ticket. So I think the only way I've been able to say that is we're starting from the train ticket, right? So we're buying a bunch of train tickets or train tickets on a test environment. So we're not actually buying them, but we're pretend buying them. And then what we're doing based on the real-time scenario of that ticket, the LLM is sampling, our user context simulator is sampling from prod to get inspiration of what questions customers might ask. And then it takes the ticket information and tries to apply relevant questions to this ticket and does it maybe 100, 1,000 times for every single ticket, and then feeds that into the assistant. Does that make sense?
Yeah, it does. So what I love about this is you're sampling production data. So you're solving this. My data set is only as good as how well it represents production, because now we can sample from production. And you're combining it with real-time data. So like, how well is my assistant doing with, like, in this moment, what's going to happen next? What I'm curious about is cost. It seems like this could get very expensive.
Yep. So actually, from an LLM point of view, it's not too bad. I mean, particularly with some of you might have seen Claude 4.5 Haiku has recently been released. Yeah. So that perspective wasn't bad. The bigger thing we were worried about was the ticket buying process in our testing environment, because what we didn't want to do was max out the testing environment, which is used by other services. Based on this. So that was more of a concern. And that's why we've approached it. Buy one ticket and then ask maybe 1,000 questions based on that one ticket. And then buy another ticket and then ask 1,000 questions based on that. On our first iteration, we were buying one ticket, asking one question and doing that again. And it was taking like 1 minute per like query, which obviously wasn't scalable. So instead we were like, buy one ticket, and then we're going to try and fit all of these queries to that specific ticket.
I want to highlight something that you just dismissed, which I find remarkable. Cost is not a concern. That tells me your small models are doing a lot of heavy lifting in your system. Is that true?
Yeah, so yes. I mean, we are obviously very careful with cost. The reason I say obviously cost is a concern to us in terms of the system generally, just to put it back in context, but cost wasn't a concern in this specific use case, because actually, even if we're doing maybe like 100,000 queries, if we're running that maybe once a month or on an individual release, compared to we have 250,000 conversations in prod currently. Yeah. If we're using a smaller model, there's about 1/10 of the cost of our production model for this. Actually, comparatively to our production costs, it doesn't significantly add much, and evaluation is a very important investment. Just to be clear, cost is very important to us. But what I meant in this case was like, cost wasn't a huge concern in this case because
relatively
wasn't huge.
Yeah.
The trade-off though with cost is interesting, because that's another thing that I think we have to consider more now that perhaps as product people we didn't previously. When we're making decisions around how we solve problems, the cost, whether that's economic or even environmental as well, the cost of how we solve problems is much, much more of a factor. And I think that's something that we'll have to consider as an industry much more than we've previously always been able to in the kind of cloud computing era. We've almost been able to not have to worry as much about that perhaps even before that we did. And so now we're entering this slightly scary new world where that will become more of a consideration, more of a factor in terms of how we approach problems as well.
Yeah, I guess the reason why the cost piece felt remarkable to me is it's a statement of just how much costs is going down with these models and like the volume we can do as that cost goes down. Matt, I'm curious, is this because, did I understand right? You mentioned you're using smaller models relative to production. Is that your LLM as judges are using smaller models, or are you actually running the assistant on a smaller model compared to production when you do evals?
Yeah, so the assistant is run on Claude 4 currently, and we always try to keep updated to the latest version. We've essentially made it agnostic of a model. Yeah, we use a number of different models depending on the task. So for simpler tasks, specific tasks, we use smaller models to keep the costs low.
Yeah.
And then for bigger tasks, and even in the assistant, we use different models. So for example, we're using Haiku for the brag summarization task compared to the reasoning task where you need to do much more heavy lifting. So yeah, that's the kind of cost engineering we do. The other option, which we haven't approached yet, and to be honest, we're wondering whether we need to, is you can fine tune smaller models for specific tasks.
Yeah.
However, as you alluded to, the costs are coming down so quickly. And if you look at Claude 4.5 Haiku, we haven't tested it ourselves yet, but in terms of the results, if you're seeing them, it's near frontier level, and it's a third of the cost of
the 4.5 Haiku release is mind blowing. That's also what's fun about being right on the edge, right? Even full 4.5 to me compared to 4 is mind blowing. And now we just got a small model that looks like it's pretty close in performance at a fraction of the cost, which is pretty crazy.
Exactly. So what is the value of fine tuning then? Do you end up in a situation where you don't actually need to follow that pattern for cost reduction because the costs are just going to come down anyway in 6 months' time, for example?
Yeah. All right. We are coming up on our scheduled time. I have one last question for the group, which is what's next for your travel assistant?
Yeah, so I can take this one. So I think there's basically an infinite possibility of kind of the problems that we can go after and solve. We know that there is a load more that we want to do, that we can do, or we can now do, perhaps is a better way of saying it. We want to ensure that we're solving a lot of these. We want to integrate more tools. We want to be able to provide more answers to customers and, of course, better answers. And really, that's the two angles that I think that we're going to explore next, as well as hopefully being able to offer it to new customers and different customers as well. So really making sure that we can get this in front of as many people as possible and is able to solve their problems as best as possible.
Amazing. This has been really fun. I love the work you're doing in the eval space. I love that you started with the agent from day one, especially a year ago, which is quite bold. And I love that it sounds like it's working out and you're helping a ton of people find their way on trains, which is a great problem space to be chipping away at. Thank you, all three of you, for joining me today. It's been really enlightening.
Thanks so much.
Thank you.
Thanks so much, Teresa.
If you enjoyed this conversation, please subscribe in your favorite podcast app and give us a rating as it helps others find the show. Thanks, I appreciate it.